Good evening, ladies and gentlemen. Am I clipping on the audio, Mr. Producer over there?
Nope.
No? I'm all good? Alright, I'm gonna trust you on this one.
Don't.
Don't? Okay,
It's
well,
a joke.
that doesn't really instill confidence, and I can't really hear myself. Let's see. Just give me 1 second here.
I can hear you.
Testing, testing.
Let me hear you through the stream.
Testing, testing. 1, 2, 3. Testing, testing. 1, 2, 3.
You're all good.
I can't hear myself.
You're all good.
I'm all good? Okay. Alright, well. Good evening, ladies and gentlemen. Welcome to the AstroCast Live. I'm Joseph Sees. We've got in the producer box over there.
Oh, give me a second. New keys.
You've
Hello.
got Matthew Barrera, who doesn't have a microphone still because it's in the mail and it's arriving tomorrow. We've got we were all ready, and then Cameron broke it.
Oh yeah, I broke it.
It's all your fault.
It's all my
all
fault.
your fault. Now my
All
cowboy hat's all messed up.
It's this guy's fault that I'm pointing to. This guy.
Alright, I'll try one more time. To see if
Yeah,
it
try it
works
one more
this
time.
You
Go to
can't
toner 2. Hold on. We'll fix this on the fly. Go to toner 2.
There.
Default.
Oh,
Uh-huh.
I hear myself.
Microphone. No.
Isn't it toner?
No.
Top toner?
Microphone toner.
Microphone toner. Not.
Right
Yep,
there.
that one.
Right there.
There we
Okay.
go. Wait, no. Yeah.
Yep.
Yeah.
It's that one?
Yay.
This one. Yeah.
Okay.
Crisis averted.
All right.
Hello, I'm the other dude that they were trying. They were attempting to point to me, but that didn't
Thank
really
you.
work. But I'm here now. Hello, hello, hi, 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 hello.
All right. You can switch back to me.
Hold on, just lag. So. There you go.
We work. Are we good? What do you do in the microphones, man? They
I'm
were
sorry,
good.
'cause I can't.
They were good just the way they are.
Mine is pointed that
That's
way. So
okay.
you can't hear me.
It's all right.
Here, I'll hold
No,
it.
you're not gonna hold your microphone.
Fine.
It's gonna be all right. We had
It's
it
not
all
gonna
set up.
work.
Look. Okay. We're perfect. We're perfect right there. We don't need to change anything. Right. We're perfect.
Oh, I think.
All right. Well, this is off to a rocky start, but we've got a full
start.
crew tonight. We don't have a special guest. We might have one next week.
Yeah.
We might have a special guest next week, and we'll do a special debate series. So you got that to look forward to. But tonight, before we get started, there's Matthew's cue to do your
Intro.
your cue. Nope, nope.
Ads,
You
ads,
said
ads,
intro.
ads, ads. There you go.
Dude, I love it. We do the same thing every night, and every time you guys come here, it's like you've never done it before. It's
There's
hilarious.
like 1,000 new keys. I
We
memorized
haven't.
what
Okay.
it
Alright,
Okay.
alright,
Well,
let's do it.
anyway,
So-
anyway, we've got. Let's see. No, it's my microphone this time.
Okay.
I just switched it to you. I messed it up last time.
You did.
But anyway, yeah, we've got a YouTube channel. You're watching on it right now. If you would be so kind to subscribe to that YouTube channel, I'd be much obliged. Let's see, what else we got? You can find us anywhere you find your podcast: Apple Music, Spotify, Google Podcasts, or I guess it's Apple Podcasts, huh? Anywhere you find your podcasts. You can follow me at joe.czall on Instagram. And is there anything anybody else wants to shout out before we get started?
Subscribe. Wait, it's not on me.
It's not on
Wait.
you. You can
I
switch
don't
it to
want
camera.
be on it.
Subscribe to Clone Trooper 2.0.
This is why I didn't switch to.
We got that. And yeah, if you would, if you have something to comment, the chat's open. If you've got something to comment and you're watching this after the fact, put it in the comments and I will respond to them.
Everyone says a good time for an ad break.
A good time for an ad break.
Yeah,
It's
do an
always a
ad
good
break.
time for an ad. We
Ad
just
break.
did an ad break. We don't need
Ad
another
break,
one.
Ad break. Ad break.
No,
Alright.
don't do it. Don't
break.
listen to Cameron. Cameron's not in charge here. All right. Well,
Ad
tonight.
break.
Tonight we're going to be talking about something that is really interesting to me and I think to everyone here, and that is Cameron got a haircut.
Why won't let me switch?
It equals.
Good job. Good job, Joe
Um,
or Matthew.
Why isn't it? Oh, there it goes.
My hair is this long. It used to, like this long. It used to be down to here.
It's on me for some reason.
But now
Oh, no, it's on you.
it's short.
Never mind.
It's shorter, not short. It's not
I got a
really
haircut
that short.
today too.
Cameron's
Yeah,
beautiful
I
beard
got a
is
haircut.
His beautiful beard. You gotta switch it to me.
Yeah, producer! Woo! Let's give a hand to our producer.
Cameron, look, I can't
Good
switch it.
job.
What the hell's going on? Do I need to get you a new keyboard? Is your
Works.
keyboard is that keyboard might be broken? You know what? Put it on Cameron. Cameron, stall for me. Keep it family friendly.
Oh, okay.
I'm not
alright.
handing this to you. I'm pointing at you.
I thought you were.
I think it's
How
push
should
it
I
at the
know?
bottom
Alright,
here.
Oh,
so-
press it?
Oh.
You figured it out?
Yeah, I figured it out.
Okay. We're gonna go with it then.
Bozo moment.
Joshua
We're gonna
Groff
go
said
with it.
something. You want me to say
Bozo.
it?
We'll keep all the chats until about halfway through.
No.
I'll read the chats on my phone
Oh no. I'm taking this off.
when I
It's
get
too
the
hot.
chance.
All right. Well, to start us off tonight,
Just
Matthew,
thought of
I have a question for you.
Uh-oh.
Actually, you don't have a microphone. Cameron, I've got a question for you.
Oh no.
It's on camera, dude. It's on camera, and I'm talking.
Yeah, good job, Matthew. Yeah, producer!
something. Try it. You gotta put
Oh,
the
Yeah,
dude, this is interesting, man. All right, Cameron, I've got a question for you.
Mhm.
Why are we here?
Yes, we are here.
We're here.
We live in a society.
Okay. Well, maybe I should see. This is why I wanted to ask Matthew, but he doesn't have a microphone.
You wanna
So-
swap? Swap.
No,
You
no.
want me to produce
I
your
don't.
camera?
I don't think I want
Yeah,
you to be
me
the producer.
producer. I know what I'm doing, guys.
I don't
Cameron,
think you
if you're
do.
a producer,
I don't
you
think
push
you do.
it here.
Yeah.
You can switch. Well, anyway, we'll figure this out as we go.
Yeah.
But my real question for you, Cameron, is there's several different theories of how the universe works, how the universe is started, how the universe is going to end. Different models that we have for our universe, like the standard model, quantum physics, relativistic physics. What do you? I mean, and then there's also like different religious, theories for why we're here, how we got here, how the universe was made, stuff like that. So what I want to start this discussion on is the different theories or kind of models of how the universe started, how it's developing, and how it's going to end. And that's what I want to revolve this podcast around.
I actually have something. Matthew, swap it over.
Go for it.
I actually have something funny. I heard this once. I don't even remember where.
just kicked
yeah,
my camera.
I kicked the camera. Sorry, Joe. Here, let me move it back. There you go.
Yeah.
So it was a very, very weird, like kind of theory that I heard. It's
Uh-huh.
definitely not true. But basically, it's like the world started 5 minutes ago, and all the memories that you got were implanted in you.
Okay, I haven't heard that one.
It was something like that.
That's a cool
It was like the universe started 5 minutes ago, and everything else is just like brain processing that happened before or like after the fact or something like that. It's
So-
something really weird.
Yeah, no, you're onto something right there. Here, Matthew, put it on the one where it's both of us, but swap
On
between
Joe
our
mic.
different
Is that
microphones.
scene two, screen
Yes.
two?
So then bring up seat 2 on the other side.
Scene two on the other side.
Yeah, so press seat
So
2.
the C2 screen.
Perfect. Now you can swap between them, and it'll be like a seamless zipper, right, Matthew?
Oh, I see what you mean. Who's toner one? You.
I'm toner 1.
Okay.
So we're on me right now. We got to get a better setup here, and I mean, I've ordered 2
Hanging
microphones.
mics?
Yes. I've ordered microphones on arms. So we're gonna have 2 microphones for the hosts and the guest, and then we're gonna have these microphones over there for the producer and the fact checker, and Cameron is gonna be the fact checker.
Oh no.
The independent fact checker. What are we doing? Anyway.
Matthew
So,
elbows
Yeah,
up.
no, I've heard a variation of that. I don't know if it was exactly that, but yeah, the universe started 5 minutes ago, and like your reality right now is reality, and there's nothing in the past, and there's nothing in
Yeah.
the future. And so that is a what's the word? No,
Let me search it
you
up.
gotta look it up because that's a really good one. It was like and then if you're not observing something, does it really exist?
Yeah.
What is that theory called? It's not stoicism because that's completely different. That's a philosophical thing. But no, it's like it's maybe relativism. Or
It's called the 5 minute hypothesis.
okay, it's not that. But yeah, it's like if you're observing something, if you're not observing something, is it really there? You know, if a tree falls in the forest, does it really make a sound, kind of thing. And that's really interesting to me because honestly, the only experience or the only thing we have to go on, like, for our own lived experience is, you know, our own lived experience. We can't see through other eyes. We can't, you know, see in other places. We only have one perspective, and it's ours. We're not omnipresent. We're not omnipotent.
Matthew's faces that he's making right now. He's making some strange faces.
Yeah, what are you doing over there, my friend?
I just made a face.
He's just like,
mind your own business.
He says mind his own business. All right, well, that's a really intriguing theory, and I don't think it has much merit,
no, of course not.
but it's a really interesting thought experiment because we only really do have our own perspective. It's hard for us as humans to see through others' perspectives just because of that fact. We have one perspective, you know.
Matthew's raising his hand.
Josh says, "Are we in a computer simulation?"
No.
Yes.
We are not in a computer simulation.
Swap to me,
Do you know
Matthew.
why we're in? Hold on, I'm talking.
No,
You
I'm
can't just
interrupting.
interrupt
I'm
me, man.
interrupting.
You can't just interrupt me.
I'm pulling the Joe.
You can talk in like 5 minutes. No, okay, I'll be very brief. We're not in a computer simulation because of irrational numbers. If we were in a computer simulation, irrational numbers would not have an infinite number of digits because it's impossible to program infinity.
Josh, we're in a video game. We really are in a video game. Trust
No.
me. I'm completely serious. We're in a video game.
Are you a camera?
Yeah,
Is
that was
literally
it.
all you had to say?
That was all I wanted to say.
I was expecting this grand like gesture, you know, this
No.
grand thought.
What
like,
do you
provoking
expect
statement.
from me, Joe?
I expected much more than that.
You shouldn't expect anything from me.
I expected much more than that. Well,
Joe. Matthew, what is that message in the chat?
I think we need to take Cameron's chat privileges away.
No, that wasn't me. That was Matthew.
I-
What he sent? You tell me to take my privileges
I'm gonna
away,
take
bro.
Matthew's privileges
Yeah,
away.
bro, you should've
I'm
seen
gonna
what
put
he
you
did
in
last
timeout.
time.
I was like,
I'm gonna put him in
I was-
timeout.
I was waiting. Is it worth Joe getting mad at me for saying that word? And I was like, yes, yes it is.
No, I agree, Matthew. Good job.
Oh, brother. All right, well, getting us back on track. The theory that I want to start us out on is quantum mechanics. Specifically, the standard model versus string theory. Now, are either of you familiar with string theory?
Let's say we don't just for the, well, actually, yeah. Let's swap. Let's say that we don't, just so that everyone else can understand it if
Okay.
they don't understand it.
So, this is a very basic understanding of string theory. Now, string theory is an incredibly complicated model, and quite frankly, I've been researching it since I was in 7th grade, and I still am no closer to fully understanding it. In fact, I would say I really don't understand it. It's really complicated. I mean, same with quantum mechanics, man. It's just it's really convoluted stuff that just doesn't make intuitive sense a lot of times. And there's some parts that do, and I'm going to explain those parts because those are the most easy concepts to grasp. So, in the standard model, you've got things called, well, okay. Give me something to hold. Okay, here. This parrot. Oh, perfect. Cameron's phone.
It's still on. Turn it off.
Oh.
There you go.
All right. This is Cameron's phone. If I chuck, I'm kidding.
I mean, it would be completely fine.
No. So if we zoom into Cameron's phone, you don't have to zoom in like on the camera. I'm just hypothetically. If we zoom into Cameron's phone,
I'm zooming.
don't zoom in. If we zoom into Cameron's phone, we're gonna, and we get smaller and smaller and smaller. Obviously, we're gonna get to a point where you can no longer, zoom in. Essentially, you're gonna get to a point where you can no longer. The experiment that I always liked, that middle schoolers always do, is they take a sheet of aluminum foil and they cut it in half until they can't cut it in half anymore. And that's like your representation of an atom. That's what an atom is, and it's from the Greek word atomos or something like that. I forget what it is. I'm not Greek and I don't speak Greek or whatever the language is. Anyway, comes from Greeks, and it means the essentially not divisible anymore, is what my memory is telling me. But it actually is divisible.
Atomos.
Atomos.
Yeah.
Atomos. Thank you, Matthew.
Matthew searched it out.
And so when you zoom into Cameron's phone, it's made up of these molecules, and those molecules are made up of atoms. And those atoms... Sorry, thank you.
Matt.
Those atoms are essentially the building blocks of our universe, or so we thought. Then we figured out that we could zoom into these atoms even more, and we found there's these things called electrons, protons, and neutrons, eventually. We didn't find that out all at the same time. We went through a long period of different models of looking at the atom, but eventually we found, the electron, the proton, the neutron. The electron are these tiny little particles, and when I say tiny, like an atom is incomprehensibly tiny. An electron on the scale of an atom is tiny. So imagine how tiny that is, and it's really small.
Well, and then also,
if you blew up an atom to the size of a football field, an atom or a electron would be the size of a blueberry. That's how small electrons are.
Matthew, swap to me so I can talk. So, Joe, is it true that most of the atom is like just empty space?
Yes, it is. Most of the atom is empty space. You've got this solid chunk, which is the nucleus, and then you've got these electrons whizzing around it in an electron cloud, which, by the way, we didn't always know. A lot of this is kind of recent discovery. Recent being like from the 1900s on. Like, this is all kind of recent stuff. Before all of us, but still kind of recent stuff. Matthew's like being a stalker and taking photos of us.
No, he's taking photos. He's taking
It's a
photos
camera.
of me.
All right, well,
What a creep.
anyway. When you go so electrons, the negative charged particle. They have very little mass, but they have a negative charge, and it's an elementary particle. Then you get into the nucleus of the atom, and you've got your neutrons and protons. Now, the neutrons are there to make sure that the protons don't all repel each other, because they're all positively charged. Proton, positively charged. And we used to think that they were also elementary particles. But then we zoomed in even more when we got this thing called the Large Hadron Collider, or particle accelerator, and we could break up those protons into smaller particles. And we found out that there's these things called quarks. Now, these are all fermions.
What is that?
I'm getting there. There are 3 types of normal matter. Well, technically there's 2 types. String theory says there's 3 types, and then says there's 2 types again, and it's really confusing, and I'll explain that. For the sake of this, there's 2 types of normal matter. Fermions and bosons.
Bozos.
Fermions are the building blocks. They make up stuff. Bosons have to do with all the interactions between particles. Like, your electron is your electromagnetic spectrum. The Higgs boson has to do with mass. The what other bosons are there? I don't know off the top of my head. Matthew, I'm sure, could find a nice diagram for us.
Joe, he pointed at me. I'm the other boson.
Oh, okay, well, essentially, these are the types of normal matter, or elementary particles, normal matter, that makes up atoms. And then on the fermion side, you have up quarks, down quarks. I think there's something called like a weird quark. Just look up bosons and fermions chart. And you're looking it up on the wrong computer.
Oh, you want it?
No, they're both the same screen. Yeah, we mirrored them this time. So, anyway, well, he gets that. Now, string theory. So this is all stuff we've observed, and this is stuff that we know, or at least we think we know, is elementary. That's stuff we've all observed. And now string theory is trying to say, well, okay, this is how we have these particles. And essentially what string theory says, it says that all of these different particles, instead of particles, if you zoom in on them, they're actually just wiggly strings. And these wiggly strings are either open strings or they're closed strings. meaning a circle that wiggles or a line that wiggles. And based on the harmonics of the wiggling, and if it's open or closed, determines the type of particle. I don't exactly know which of which determines what, but the basic part, the type of wiggling, and if it's closed or open, determines what type of particle it is on the standard model. Now, in this model that string theory is presented, it takes 26 physical dimensions to actually get all of the particles that we know. And the math is beyond me on that part, how they got to that number. And additionally, it also, they get some sort of imaginary number output from one of their equations. And this is, have you guys ever heard of the tachyon? No? Okay, well, I'm just a science nerd, so. Anyway, the string theory originally predicted this particle called a tachyon. And this was an imaginary number-based particle that didn't it didn't really have a basis in real life, and it was more of like a prediction. We predict that to see this if our theory is correct. Now, you can't really have you know what an imaginary number is, right? It's the square root of a negative number, which is physically impossible. But theoretically, you can take it's useful in math and in actual real world applications. But it's actually, fun fact, that's actually where we get the derivation of sine and cosine. Is the exponential, or e to the power of I, produces a cosine and a sine, I think.
Really?
I want to say so, because in differential equations.
E to the power of I.
E to the power of it produces cosine t plus sine t.
Cosine plus I sine.
Yeah. Oh, yes. Cosine t plus I sine t. Yes.
I did not know that.
Aren't you taking differential equations right now?
Yeah, but I never did e to the power.
That should be how you solve your imaginary, what kind of problem is that? Undetermined coefficients. That's your second order that's your second order linear non-homogeneous. Second order non-linear
homo.
No? Oh.
By the way, Edward mentions white holes.
Oh, white holes.
I'll get to that in just a second, Edward. I will get to that in just... Oh, wait. Sorry, wrong camera. I will get to that in just a second. I've been looking at that camera the whole time, man.
Joe.
I know. Shame on me. So, anyway.
I saw the video. I didn't see the video, but I saw it on YouTube where it said, "We just discovered white holes."
So, you know what? Since you brought that up, that is a complete scam. It is completely wrong. No, I honestly wanted that to be true, and I even sent that to you, Matthew.
Yeah.
And I was like, we need to talk about this on the podcast. This is an amazing discovery. And I looked at it, and the guy was just lying. He had no sources. And the source he was referencing was from 2006, where they think maybe it could possibly be a white hole, but it's just a gamma ray burst.
So what it
lies?
explain what white holes are.
Okay, let me finish string theory, and then we'll get into that. Essentially, they end up putting these things called spinors on the strings, and then that gives us something called supersymmetry between the fermions and the bosons, meaning we have the same number of fermions as there are bosons. And the model that we have now is kind of close to that string theory model, and so it's on the right track, is what most people tend to see, but I don't think it's there yet. And obviously, you know, my opinion is kind of irrelevant in the discussion because I'm a nobody from nowhere. So he's just but yeah, I don't have much scientific sway, but in my opinion, my humble opinion, string theory still has a lot to get through and a lot to prove before they are no, it's honestly, it's a really solid theory, and it predicts a lot of stuff that we have been able to see and observe. But it's I don't know, I just typically don't really like it because of how complex it is. And I feel like the universe is going to be complex, but I feel like at the fundamental level, it's going to be simpler than the math involved with string theory.
We're overcomplicating it.
That's my opinion. I could be totally wrong. I probably am wrong. But typically that's my opinion. Now, let's talk about black holes and white holes. Cameron.
What?
Don't.
My faces?
Now, everyone knows what a black hole is. If you're a watcher of this show, you definitely know what a black hole is. Essentially, it is a large mass in space, or it's a star that collapses upon its own weight and condenses into this really dense ball of mass that is so dense that it warps space and time to a singularity, meaning to a single point where gravity is so strong that even light cannot escape the event horizon, which is why we call it a black hole, because we physically cannot see that part in space because light does not emit from it. Now, Hawking radiation does actually emit from black holes, but it's not really the black hole emitting it. It's light that barely touches the event horizon and then whizzes off and changes its frequency a little bit, is my understanding. There's also X-ray bursts at the poles of black holes, and those are called relativistic jets, but that's only certain types of black holes, and I don't know if that's actually proven or disproven yet. But anyway, and then we can also detect it by accretion disks of when it's sucking gas off of the top layers of gas off of a neighboring star. Now, a white hole is the opposite of a black hole. Essentially, and this has not been physically observed, contrary to popular belief. A white hole is something that ejects mass away from it. Light cannot enter. It's the exact opposite. Now, the reason that we even consider this as a scientific possibility is because of something called an Einstein-Rosen bridge, or a wormhole. And essentially what that is relativity, or I think it's Einstein's theory of special relativity specifically, predicts a model of where a black hole comes to a singularity, and out the other side, essentially, if you can picture it, it's kind of like you've got your paraboloid here for the black hole that goes to a singularity point at the bottom, and then you've got the other side of the hourglass, essentially. And the theory is that that can kind of warp and bend through space-time and come out somewhere else in the universe. Now, this obviously warps and bends in 4 dimensions because of we're in a 3-dimensional space. And I'm sure people have seen the example of where you take a piece of paper. Here's my hat. You take a piece of paper, you fold it, and then you punch a pen through it.
Yeah.
Now imagine doing that in 3 dimensions. That means it's bending in 4 dimensions. Trying not to ruin my hat. Yeah, you can't really comprehend that. And essentially what that means is technically time travel. But not technically. And that's something I can't, whole can of worms I don't. Well,
you're gonna die before you actually enter.
Because the gravity is so strong, technically yes, you could spaghettify. However, relativity says, as you approach the event horizon, time for you gets increasingly slower, although it feels like time is regular, but time to the outside world is increasingly speeding up from your perspective. Therefore, in your lifetime, you will never pass the event horizon. To the outside world, you have already been You've already been dead, long gone, and sucked into the black hole. From your perspective, you are will always be on the event horizon because time moves so slowly for you.
That's scary.
You will be in perpetual.
Hell.
No, I mean, technically you'd be immortal. No, because time would move so slowly, you'd be immortal.
Stuck with your own thoughts?
No, I don't think you'd have time to think, because time would be moving so slowly.
What are you?
Nothing.
So that's my point. Maybe if you get to that point, because time is so finicky there, then the moment you hit the event horizon, you just get sucked through so fast and exit the white hole at the other side, maybe?
Joe, my head can't wrap around the fact that time can slow down.
So Matthew says his head can't wrap around the fact that time can slow down. And it slows down and speeds up every day. The faster or slower we move, time is proportional to the speed at which you move, relative to the speed of light. The faster you move, the slower time passes for you. Which means that if, for example, Cameron goes off on a trip around the sun at the speed of light, theoretically. Obviously, this is physically impossible. Zoom, indeed. Now, Cameron comes back to Earth, and he's 20 years older than me. But we're the same age. So what happened? I'm sorry, I'm 20 years older than Cameron. So what happened? Well, time moved slower for Cameron because he was moving faster. There's also, and I actually had this thought in middle school, but it's not an original thought. What happens if you break the speed of light then? If you move so fast that time stops, and then you keep going, and then time goes reverse, and then you're going... But unfortunately, you cannot break the speed of light because of conservation... is it conservation of energy or conservation of mass, or maybe both? But essentially, you cannot have information or mass traveling faster than the speed of light. A proton has no mass. It's pure energy.
And where it says time dilation?
Yes, time dilation is exactly what that is. Relativistic time dilation. And that's some trippy stuff. And that's where you get into black holes, you get into that territory. So that's what I'm saying is, while physically, yes, you are correct, there's so much gravity it would tear you apart, I'm not sure you would ever perceive or be able to perceive that happening to you. I think you would slow down to a point where then it'd be so fast you'd already be out the other side of the white hole, if white holes exist, and if that model is correct. That's my theory.
Let's send somebody.
Yeah, let's test that theory. Cameron, let's
test
get you
it.
in a rocket ship and send you straight into the heart of the Milky Way.
Time to go to the moon.
The moon doesn't have black hole.
Yes, it does. Trust me, it's inside. It's in the middle.
What, like Brittle Hollow in Outer Worlds? Or Outer Wilds? That's a good game, by the way. Which is a perfect segue into quantum mechanics.
Alright, hold on.
Go
Matthew,
for it.
swap to Joe.
Wait, swap to
Just
Joe?
Joe.
Just Joe.
Just Joe.
Okay. It's on Just Joe. Welcome to the Just Joe show. What do you need? What do you need? What are you trying to do?
I'm gonna get a drink.
Do you need me to hand you your water?
No, it's done.
Uh,
I finished it.
Why are you so thirsty?
I'm not thirsty. That sounds so bad.
All right, well, quantum mechanics is kind of similar to the standard model in string theory. I mean, sorry, not really similar, but it's in the same ballpark. You want to sit over here since he's...
Yeah.
You got to switch it to both of us, though,
Oh.
before you go.
But I have to switch mics.
Yeah, that's not going to work. Never mind. That's not going to work.
Ish kindly said, I don't give a heck about quantum mechanics.
Well, quantum mechanics, we had a chat saying I don't care about quantum mechanics. Well, quantum mechanics is really overly complicated, and it's honestly, man, it's really complicated, and it's really hard to wrap your head around, and I definitely haven't wrapped my head around it.
Joe, let's switch to economics. Should Ishmael...
No, we're talking about science, man. We're not gonna switch topics right in the middle of me talking about quantum mechanics. Come on. Quantum mechanics is...
Charge itself and get electric power.
What was that?
Can a hybrid car battery charge itself and get electric power?
Can a hybrid car battery charge itself and get electric power?
Or get electric power. I don't even know what you guys mean.
I'm not sure what you're asking. If you run the gasoline engine, then yes, the battery will recharge, because you have an alternator in the engine, and that will recharge the battery. I'm not sure what you mean by get electric power.
Matty Cheeks did not make any sense.
Yeah,
Tell him
not
to
really.
restate his whatever he wants.
Yeah,
to say.
restate your question.
Restate your statement.
Oh, we've got our lovely Cameron back
Interruption.
for blocking. Thank you for blocking the camera. You can switch it back to the both of us now.
Got it.
All right. Well, what we were supposed to be talking about quantum mechanics.
Sorry, distracted Joe.
Yes.
So quantum mechanics. We've already talked a little bit about quantum mechanics on the podcast before, What do you know about quantum mechanics, Cameron?
Not much. I forget. It's not even on me. There we go. I forget a lot.
You forget a lot.
So I probably already forgot everything.
You remember
about it.
Schrodinger's cat?
Is that the thing where the cat is in the box and you don't know if it's alive
Yeah.
or not? Yeah.
So, Schrodinger's cat, there is a nuclear warhead attached to a box with a cat in it. Now, there is a random number generator that is purely random that will detonate the nuclear bomb 50-50 chance in a certain amount of time. And you don't know if the bomb is gone, and it's in a closed room. And let's say the nuclear bomb is small enough it will not destroy the closed room, that you don't know what's going on in the closed room. You put the cat in the box, you arm the nuke, you arm the random number generator. If it detonates or not, it's a 50-50 chance. You exit the room. Now, Schrodinger says that the cat is in a superposition of states. It is both alive and dead. Now, the reason this is because the random number generator he uses in this hypothetical thought experiment is one that is determined by quantum mechanics. Now, quantum mechanics, the principle of superposition, an electron, until something is observed, it is in a state of superposition, meaning it can be anywhere at once. Anywhere all at once. When the waveform collapses, you know exactly where it is because you've observed it. So, when you open the door to see if the cat is alive or dead, the waveform collapses and you see the result of the experiment. But up until that point, it is in a superposition of both being alive and dead. And this is why Schrodinger did not last in quantum mechanics too long, because he was like, what the hell did I just think about? And there's seriously like a few quotes from him that have been like, I mean, I'm paraphrasing because I don't remember off the top of my head, but it's like, you know, I'm slouching.
Yes, you are.
But it's like,
Scary.
who thinks of that stuff, you know?
Yeah.
I mean, I think of that stuff all the time, but
That's because you're Joe.
that's because I'm Joe, exactly. So, what's your... I want to switch topics a little bit because we've talked about quantum mechanics quite a bit, and honestly, I've had to do a lot with quantum mechanics, and I'm kind of done with it. So, you know what I want to talk about?
Yes.
Universe creation stories. Universe creation stories. You know, we've got the scientific model of the Big Bang. We've got all the different creation stories from religion. We've got how the universe is expanding from a point all at once. We've got, I don't know if any of you know Ian Crossland, but he's got a theory that instead of the universe expanding, the universe is twisting. So we can talk about that. I should actually hit him up and say, hey, we talked about your theory. I'd love to have you, love to interview you. If you're watching, we would love to interview you. Yeah, let's talk about this because let's assume that so the main evidence we have for the Big Bang is something called the Doppler shift. Mm-hmm. Now, or the red shift, which is essentially the Doppler shift but with light. As objects move away from us, they shift towards the red spectrum because those are longer wavelengths, and as something is moving away, the wavelengths elongate. And if you just move your finger in a puddle of water, you can see this for yourself. Or if for example, you have like a police car going by you on the street, it'll sound high-pitched when it's coming towards you and then get lower-pitched going away from you. That's the Doppler shift. It's the same thing with red shift, except it's just with light.
Doppler shift, Doppler effect, same thing, right?
Yeah, same thing. So that's the main evidence we have because pretty much everything we look at, the average, it's all expanding away from us. Everything. And we used to think that meant we were the center of the universe. But I would implore you to look at the raisin cake model, which is essentially you make a cake and you put raisins in it. When the cake starts off small like this, all the raisins are bunched up together. When the cake grows, it is expanding at all places all at once at the same rate. Now, if you make two layers or if you have two sheets of paper and one of them's clear. And the clear one is the final product of the cake, and the beginning one is not clear, and it's the beginning. If you put the final product on the hold on the cake of the original, and then you put the final on top, and you line up one of the raisins, it'll look like all of the other raisins are moving away from that one raisin. Now pick another raisin that's the same as on the first one, you line it up, it'll look like all of the thing. It's because the universe is adding, space is stretching at all points at the same rate. Meaning it looks like to any one observer at one point in the universe that everything is moving away from it, because it is at a constant rate. But it doesn't mean you're the center of the universe. Now, how cool would that be if we were the center of the universe, man? That'd be really freaking cool.
We always think that.
Yeah, but
Joe,
unfortunately
you're
we're
the
not.
center of your universe.
No.
There we go.
Nope.
Joe.
Nope.
Is there
All right, what was your question, Matthew?
Is there a great attractor in the universe, and is it possible that it is the reason behind universal expansion? That's what Joshua.
Is there a great attractor in the
Joe,
universe?
you're a great attractor.
Thank you, Cameron.
You're welcome.
Is there a great attractor in the universe, and is that the reason for expansion? Who knows?
Who knows?
Who knows? I'm probably way too close to the microphone. The main theory we have for the expansion of the universe is something called dark energy. Now, dark energy is, the reason it's called dark energy is because we don't know what the hell it is, or even if it exists. So, we call it dark energy because it's energy that we don't know where it is, why it is, how it is, but we know that there is some energy that is expanding the universe, because we know the universe is expanding. And we know that pretty much for certain because of that Doppler shift. I mean, it's pretty damning evidence. Now,
The definition for the great attractor is weird.
yeah, so the great attractor is a theory that there's something that's pulling everything apart.
Central gravitational point of the Laniakea supercluster. That's what it says.
Okay, well, that's something different.
What? This is right here. Okay. The
That's...
great attractor is a gravitational anomaly in the intergalactic space.
Oh,
Near
oh,
its
oh.
central gravitational point, the Laniakea supercluster. Can't say.
Okay. Well, so I'm not sure what that is then. You might have to do some research on that, Matthew, because I'm not sure what that is.
Alright.
But I do remember, you know, there are theories of people who say, you know, well, what's pushing it or what's pulling it? Is it being pushed or pulled? You know, and what's doing it? And to be honest, we don't really know. It could just be. Oh, so for a long time, we thought it was we thought it was extra momentum left over from the Big Bang, of just, you know, it's expanding since there's no, you know, drag in space. It's just going to expand forever. The problem with that model is entropy. And entropy says, you know, the chaos basically of the universe has to increase over time. And that's the second law of thermodynamics. And essentially what that means is you can't, if you cool something down, something else has to heat up. And the more you heat stuff, this is kind of like the proponents of the eventual heat death of the universe. Entropy is going to become so great that everything just heats up so much that everything just, like, I forget the end result, but what? You found more information?
Yeah.
Okay,
Wanna read it?
let's hear it.
Our galaxy and other nearby galaxies are being pulled towards a specific region of space. It's about 150 million light years away. And here's the best part: we're not exactly sure what it is, but it's called a great attractor. Part of the reason the great attractor is so mysterious is that it happens to light in the direction of the sky known as the zone of avoidance. This is in the general direction of the center of our galaxy, where there's nothing, no gas, no dust, and we can't see very far in the visible spectrum.
Well, that's interesting, because at the center of our galaxy, we have the Milky Way. We have a big old black hole.
Massive over there.
But if they're saying it's in a different spot than the black hole,
Well, here's something cool
Go
that
for it.
I would like to. Matthew, am I on? Put me on.
Sorry.
So, you know how we have Earth, right? It's
Yes.
Earth.
I know Earth.
Well, yes, and then we have the sun, solar system,
Mhm.
galaxies,
Mhm.
universe. So just as the Earth rotates around the sun rotates around the galaxy. then imagine if the galaxy is rotating around a black hole, massive black hole. And so that's another, like, super galaxy or something. Imagine that. That would be cool. What? You're looking at me weird, but, like, it kind of goes with the Great Attractor where there's,
The
like...
Great Attractor is local to our galaxy, I do believe.
Okay, well, I'm talking about the universe. So there's, like, a big center something.
So you're
right?
saying the Eye of the Universe?
Eye of the Universe!
You go from Outer Wilds?
I've never actually played, so I wouldn't know.
Oh.
But, so there's, like, the center of the universe. And it's just like there's a center of a galaxy, which is a black hole. There's the center of the universe, and all the galaxies are rotating around it.
There's not really much evidence for that.
Well, of course not.
You're just thinking it's cool?
I'm just saying
Okay,
something that
okay.
sounds cool.
Gotcha. Unfortunately, the evidence we have suggests that everything's just expanding.
Well, yes,
Um,
of course, yes.
I suppose because it's happening on such a large scale, it could be that it's rotating. It's just so imperceivable to us because it's happening at such a large scale. I suppose the argument could be made for that. You'd have to find some other way of proving that hypothesis, however.
Of course. But we don't have the technology.
I think it's more we don't have the expertise or know how to even
Oh,
start
that
looking
too.
into proving that. Because you could totally prove it with math. You can prove anything with math.
Can you prove love? Ooh, got him.
I want to
got
talk
him.
about something in that regard. Have you guys seen the movie Interstellar?
Ironically, I haven't.
Okay, well
I don't think I have.
Well, essentially,
You can spoil
they
it,
bring
I don't
up.
care.
Yeah, it's an old movie. I'm going to. They bring up a point that, something along the lines of, love is this mysterious thing that scientists don't know what it is, or maybe it's like something that binds us all.
Well, it's hormones, so that's what it is.
And so, my whole picture of that. Again, I'm a confirmed Catholic, so I'm a religious guy. So I'm gonna, of course, bring religion into it. But my whole idea with that is, I think God is love, and I think God is in everything. So maybe this thing that we call love, this relationship that we have with our fellow humans, and even like my dog or dogs, you can have love towards
Other things.
I think that's something special that might even have something to play in the science realm just on the grand scheme of the universe. Honestly, I think there's a case to be made there. Because, I mean, there's been, not to be too much of a conspiracy theorist, but there are unexplainable things in this world. And there are incredible things that love has been able to do that have been unexplainable or like improbable on the science side of things. So I almost wonder if there's some force, in my perspective that would probably be God, that's in the universe, is the universe, but binds us all together, almost like the Force in Star Wars.
Once you said binds, I was like, oh
Yeah.
my god, he's talking about the freaking
Almost like
Force.
the Force in Star Wars, but honestly, like that's kind of how I
Penetrates us,
picture God,
surrounds us.
But yeah, and again, I go back to the book in Exodus when Moses, when he tells Moses who he is, I am who am, I am that is, I am in everything, and I am that am. I think that's probably the best definition. What's your opinion on that, Cameron?
Yes.
No, come on, have a little more nuance than that.
You just mean the whole thing, or just I am that am?
Everything.
So everything, so that love makes the world go around.
Well, I didn't say that. But I said there is some kind of force in this universe that has something at larger to play. And I think that has something to do with love, and I think that has something to do with God, and I think they're one and the same, and I think there's something going on there.
I think it has something to do with the fourth dimension that we
The
can't
fourth
see.
dimension.
That we can't see.
God is the fourth dimension.
He is everything. He can see the third dimension. I mean, it makes more sense if you think about it like that.
So
wait,
yeah,
hold on. Let me explain.
Go for it.
So there's a video, Joe's seen it, I've seen it, where it shows kind of like or maybe it was a picture, I don't know. But it has, second dimension sees first dimension, third dimension sees second dimension, and so you can see, so third dimension can see all of the line, right? It's a line. Second dimension is a line.
Can I explain it
So
a
then-
little better?
Fourth dimension can see everything or inside, outside of the third dimension.
Yeah.
I didn't explain it very well at all.
So
He'll
here's
explain it.
the explanation.
Yes. Go ahead.
Imagine a point. If you move that point, what do you get? You get a line. There's your first dimension. Now move that line. What do you get? You get a square. Now, the square, we're in the third dimension. We can see everything inside of a square that's in 2 dimensions. Can a 2-dimensional person on a flat piece of paper see into that square through that line? They cannot. Now, let's go to the 3 dimensions. We have a cube. If you move that square, you get a cube. Can we see inside of a solid cube? Assuming it's not transparent. No. However, someone in the 4th dimension, a 4th-dimensional being, could theoretically see into the 3rd dimension like we could see into the 2nd dimension, into a square. They could see into that cube.
Oh,
and that's where we get something called the tesseract, but go into it.
I'm not going into the tesseract, but
Okay.
I'm going into the thing that you were talking about. You remember the theory with all the math and everything that you were trying to prove with the 4th
Yes.
dimension? How
Infinite dimensions.
how many
yeah.
dimensions interact with the 3rd dimension or interact
No,
with the particle?
it was how do you determine how many dimensions a particle interacts with? And this is a theory that I'm working on where a particle's ultimate definition is defined by how it interacts with its interactions and itself its ultimate definition is defined on how and which dimensions it interacts with. And I said, okay, well then the question is which dimensions interact with a given particle. And but yeah, go on.
But yeah, that kind of applies a little bit, I guess, in a sense.
Yeah,
it
it
applies
does.
to it.
So
So the 4th dimension can interact with any single particle from the 3rd dimension.
yes, but not in the sense that I think you're thinking of. To get to the 4th dimension from the 3rd dimension, what do you do? Okay, well, to get from the 1st to the 2nd, what do you do?
Well, you move
Okay, you move. What is moving? What's that? What is moving?
position, acceleration.
No. What
Speed.
is like the definition of move? Speed. What is speed?
Speed is just
Speed is a rate,
Yeah,
right?
it's a rate.
It's a spatial unit per unit time.
it's constant, right? Well,
It doesn't
at
have to
least-
be, but for the sake of this thing, you have a point. If you move that point, what is moving the point?
Well, speed
What
is
is that?
constant until it.
Well,
gives
that doesn't matter for this.
acceleration.
That doesn't matter for this though.
Of course,
If you have a point and you move it, what are you physically doing to the point?
you're accelerating it or
You-
giving
Physically, what is happening to that point?
it is being moved.
Okay, and what does that mean? Is it so? If what I'm getting at is you have one dimension. What?
Is time passing?
Time is passing.
Yes. Okay.
Time is passing. So
Time
if you're
passes.
moving something, is there motion without time? Bingo. So if you're moving something, that means time is passing.
So you have to go.
So to go
yeah,
from the
that's right.
first
That's right.
dimension
You
to
explained
the
this to me.
second dimension,
That's right. I remember now.
You have to
I remember now.
have respect to time.
Yes.
You have to do something with time. Now to get from the 2nd to the 3rd, you again have to move something with respect to time. Except in that case, you have units of meters squared over seconds, or 2 spatial units with respect to time, or over time. To get from the 3rd to the 4th, it's the same thing. You just move something in time. In fact, to us, the 4th dimension is perceived as the passage of time. Interstellar gets into that a little kind of hokey, but
It's 9. It's all-
okay, we can go long.
Alright, we go longer.
Yeah,
It's
we
fine.
can go as long as we want. It's
Oh,
Friday.
you were saying it's time. Oh.
Like 9.
No. He was saying time like as an answer
No, I
to
know,
my
but
question.
he said earlier he said Cameron, it's time or something like that.
Yeah.
And I didn't understand what you were saying.
Yeah, that's fine.
Anyway, no, he was answering my question.
Well, no. he
It
said
doesn't
something.
matter. Anyway,
We're-
yeah,
we're
that
just delaying.
I
time.
know.
Time.
So-
time.
and that so essentially, from that perspective, there are infinite dimensions in space and time. Actually, you can have an infinite number of dimensions that interact with space and time, and you can have different mixtures of the same dimension being in different levels of space and different levels of time. For example, in our 3-dimensional world, you can have something that's represented by one dimension, like a particle, and you can have that moving in 3 different iterations of time, or 3 different levels of time, you know? So that's something that I called, in my theory, a dimensional shell, which is where you have, let's say we're in the third dimension, that means you can have 2 spatial units and a time unit, or 3 spatial units and no time unit, or 1 spatial unit and 2 time units, or any combination of time and space units, where space is over time. You can have any combination of those as long as the amount of units all adds up to 3 if we're in the third dimension. You kind of get my drift?
Because you explained it to me before.
Okay.
But they don't know. They don't know.
Well, I think that's a pretty good explanation. So, if you set a certain number, if you set, like, on the left side the maximum number of spatial dimensions, and then on the right side you set the maximum number of time dimensions, then something really interesting happens when you try to go and then meet in the middle. Something really interesting happens. When you start, let's say, with real numbers, r squared or r cubed, you know, if for those of you who are in higher level math, you'll kind of get what that means. But essentially you have 3 dimensions on the left of a space variable, or a spatial function. On the right side, then you have three variables, or 3 units of, which, by the way, are linearly independent of time. Now, as you move towards the middle on the left side, you then have 2 units of space and 1 unit of time. And you keep moving, and then you have 1 unit of space and 2 units of time. Then you move over here, you have 0 units of space and 3 units of time. Well, now, how can you have 0 units of space? So, okay, well, we'll come back to that. Let's go over to the right side. We have 3 units of time and 0 units of space. And then you have 2 units of time and 1 unit of space. Then you have 1 unit of time and 2 units of space. Then you have 3 units of time and 0. Well, wait a minute.
How can you have no time?
We have 0 units of time and 3 units of space, but we also have 0 units of time and 3 units of space. You know, we have the same, we have the same, at the same exact point in the middle, we have the same, or 2 different outcomes. You know, starting from the left and going space down to time, you then get 1 over t, or 1 over 3 t to the cubed. You know, you have 0, well, anything to the power. Yeah. You can have 0 spatial dimensions, I suppose, because that's just frequency. You know, 1 over t is just frequency. And then you can have 0 dimensions of time. It's just an immovable object, you know. So that's, you know, that's all well and good. But they don't agree when you get to the middle.
Yeah.
So I've kind of dubbed that a hidden number, because we already have imaginary numbers. So I dubbed that a hidden number, where they disagree on which dimensional variable should be at a maximum. And I don't know, I think that's kind of interesting, because it's always at that middle spot. If you start at 1 dimension and go to the middle spot, it's there. 2 dimensions, it's there. 3 dimensions, it's there. And the thing that's always interesting is when you go down the dimensions, that number is always at whatever your dimension's at. The maximum there is always at whatever your dimension's at, and it's always, the other variable is at an exponent of 0, and the first variable is always at an exponent of n, whatever, n being whatever dimension you're at. And so I just thought it was an interesting outcome. And my
if
whole...
you bring in math, what about not being able to be divisible by 0? So.
Well, it's not 0, because what's anything to the power of 0?
Isn't it 1?
It's 1. So you're not dividing by 0. I'm not breaking any laws of physics. I don't think.
It's to the power.
It's to the power.
Got it.
So
See,
essentially my function, well, so essentially my function is s over t, where s is a spatial dimension and t is a time dimension. And you have s to the power of n is equal to 1 over t to the power of n. And then you can derive from that alpha naught plus alpha 1, let's say, is equal to t, which means you can have s to the power of alpha naught over t to the power of alpha 1, where alpha 1 and alpha naught add up to equal n. And that's where you get those dimensional shells, those different variations of how many dimensions you can have. So I've gone down this rabbit hole for quite a while now, and I've been trying to take this model that I think I'm onto something, and I've been trying to take this model and derive anything from it, like anything physical and real that we observe. And so as I'm doing this, I'm adding and adjusting it to see, okay, well, this doesn't work if I do this, so maybe I have to adjust this here. And it's an interesting process because I'm trying to derive basically an ultimate definition of everything. And then I ran into that question the other day, and we were just talking about is how do you determine what dimensions a particle interacts with? Because if we have infinite dimensions and a particle can interact with infinite dimensions and each dimension has infinite number of shells, well then that's infinity squared. That's an impossible calculus to do. And well, so I made an assumption. My assumption was I'm going to tell myself this particle that I'm saying and I'm calling it a fundamental form. This fundamental form, or this particle, is going to only interact with the first dimension on the first shell. That was my solution. I'm going to tell the particle what it's going to interact with, and then I'm going to see if that derives an equation that follows what we observe in real life. And it's interesting because for some things it does, and for some things it doesn't. And so I've had to add and change how I'm deriving things, and I ended up changing the ultimate definition from a scalar, or just one function, to a vector field, or a vector of functions, where there's multiple different linearly independent functions within. Actually, not necessarily linear independent. They might be conservative, but they might not be linearly independent. Within the vector field.
Within the shell.
No.
The vector field within the shell.
No.
Yes.
But anyway, that's a lot of math talk, and I don't know if you can tell, but I'm in higher level math.
Oh no.
So
I
I'm
don't do
having
math.
all sorts of fun in differential equations, linear algebra, and calculus 3. And my original definition for this was it was going to be the integral from negative infinity to positive infinity of this function that I was deriving. And then I realized that problems was like that was my first solution to the problem of how can you have infinite dimensions and add them all up. And I was like, well, you just take the integral and then you kind of end up with a limit somewhere in there. But
that's just a limit, though.
Yeah, but that's not. No, it's just impractical. The amount of calculus you'd have to do.
Yes, and also it's just
and
a
eventually,
limit.
and if you think about it, if you add up every single possible thing in the universe, what are you gonna get? Any guess? If you add up everything, principle of superposition.
Infinity.
No.
Well, infinity
You're gonna
is not
get
a number,
0.
Matthew.
You're gonna get 0. If you add up everything in the universe, principle of superposition, everything's expanding outward from itself. Everything is entropy's increasing. It's all gonna add up to 0. So how does that help me? It doesn't. I can't just say everything's 0, nothing exists. I mean, there's actually theories that do say that. So, let's take a break from my boring math and calculus and talk about that a little bit, because technically
nothing exists, Joe.
Well, so
Your reality.
Conservation of energy and conservation
is
of mass, right?
non-existent.
If you start with the Big Bang, where there was nothing, and then it suddenly exploded and expanded, how is that possible? How can you go from nothing to something?
Well, see, then that would mean that there had to have been something beforehand in order for it to
Yes.
exist in the first place.
But what made that?
What came first, the chicken or the egg?
Yeah. What came first, the chicken or the egg? Is
Well,
what Matthew says.
that could go back to the. No, I don't think there's probably a theory on this, but like back to that there was a world existent or a universe existent before our universe.
Okay, then what created that one?
Another universe before
So
it.
there has to. My point
infinite
is there has to be a
universes.
definitive start. No, even if your multiverse theory is correct, which is Neil deGrasse Tyson is a proponent of that theory, by the way, exactly what you just said. There has to be a start somewhere. Unless you think... I forgot about this theory, though. There is a theory that it's a loop. A closed loop.
Like,
Meaning...
like the thing in Marvel Infinity War where it's like the...
Loki. You're thinking of Loki.
No. I'm thinking of Infinity War? Endgame. Endgame where he finds like the time... whatever. What is it called?
Time stone?
No, not the time stone.
Eye
You
of
know when
Agamotto?
Stark was looking at like...
Oh,
and he's
it's
looking
true,
at that
actually.
one... When they were creating the time machine.
Yeah.
And Stark said, I did it!
Oh, an inverted Mobius strip.
Yes, a Mobius strip.
No, not like that.
No, it worked.
So it on just a closed loop. It doesn't matter what shape it is. A closed loop always returns upon itself. And there's something mathematically magical about a closed loop. There's a lot of different theorems and theories that have to do with that, and they're really interesting. And I suggest you look at like Green's theorem and Stokes' theorem. Well, actually, yeah, Stokes' theorem, or the what was the other one? Gosh. The divergence theorem. That's another good one with a closed... that one's actually a closed surface. But what I'm getting at is if your start is also your end, then there never was anything. And so there is actually a prominent theory that says all of this doesn't exist. We're a momentary blip in the process between nothing and nothing. Where it basically... it's just a loop, you know. It's returning back to the start, and in your case, it's going to expand and can then contract, and then expand and then contract.
Edward says if it is a loop, how does the Big Bang work with the loop theory, since the Big Bang suggests the beginning?
So that's what we were just discussing, and that was actually what Cameron said, is that there was a universe that, let's say, after it's done expanding, then it's going to contract upon itself and condense, and then when it condenses, it's going to be another Big Bang, and then it's going to keep going over and over and over.
Makes sense, though.
And that's what I don't like about it, is the math is too good to be true.
Well, then you also have to think of what is it? What is the physics thing where it's like everything loses energy no matter what?
Entropy.
Entropy. Okay, yeah. So everything loses energy. So maybe it's gonna go.
So if there was, so that would be a damping function.
Universe has a damping function.
That would
confirmed.
be a second order homogeneous. That'd be a second order non-homogeneous linear differential equation right there, and that's not nothing. That would. That's not nothing.
Material, Joe. His face.
Oh yeah, I'm gonna totally get that for a clip thumbnail.
You're gonna be the front.
wait, hold on. Ready?
3, 2, 1. That's
Oh, this is gonna be great. This is gonna
Thumbnail.
be great. Matthew, you're gonna
Thumbnails
be
are
busy
bad.
making thumbnails.
I can't do
Do it, Matthew. Oh yeah. Yeah, no, and then
I'm
then
totally
you
gonna use
clip
these for
Matthew's
thumbnails.
Face in the corner.
I just made a thumbnail this morning of Cameron's head like opening to reveal a brain and then a rocket ship crashing into it. It's great. That'll be out next week sometime. I can't wait for that one. But
Joe, before we end,
Yeah.
Ish has a pressing
Here, let me see.
issue.
Let me
Oh
read it.
yes. I got it over here.
It's,
Oh, okay.
It's
I'll read it.
choose between 3 things.
I'll read it. Alright, let me find it real quick. I'll read it. Or maybe Cameron will read it.
Where is this?
It's up there. It says, it's right here.
I
I
learned.
have 3%. It says, which is better? Read it.
Which is better, virtual reality, a middle-aged weapon that can separate atoms, or an invention that has noise cancellation to ignore people?
Who wants to know what to buy?
The last one. Last one.
A middle-aged weapon that can... You mean like from the Middle Ages?
A katana.
Oh, definitely the katana. Definitely the katana.
Noise cancellation. Dude, screw people.
I don't think you give people enough chance. Have a little more patience and grace.
Screw you.
See, I think if we had a little more patience and grace in this world, people aren't bad.
I'd like to
Disagree?
disagree with
You're
that.
disagreeing?
Hey, skip
There
back to
there
YouTube
are
clips.
fundamentally ill people.
No, there are bad people, but that doesn't mean human nature is bad.
No, all of us start out as
I
a
think
blank
if you
slate.
if you give somebody a chance, and if you really listen to somebody, and not just once, and even if they're an asshat to you, every single time you do it,
And-
you have to keep trying. You know, you can't just say, well, you know, they're a lost cause. Nobody's a lost cause. And I truly believe that.
Edwards said, but if the universe is constantly expanding, what evidence is there to show that the universe condenses again to recreate the loop?
What evidence is there that it doesn't?
Ooh.
I mean, there's no evidence either way, other than the fact that we think that the universe is accelerating away from us at a
Well,
at
here.
well, it's hold
I've
on.
got something.
There is evidence that suggests that the universe is accelerating away from itself, which would contradict that the universe collapses in on itself again. And by the way, I'm not saying I agree with any of these theories. I'm just telling them as I've researched them. But
It wouldn't be
there,
the case.
Hold
Hold on.
you know, there could be a function. It could be like a sine wave. You know, acceleration, constant velocity, deceleration, constant velocity, acceleration. You know, it could be a. Who
Well, here,
knows
let
what
me-
the function of position of our universe is?
I've got
Go for
something.
it.
So that would be the case unless it's an implosion type thing, and implosions only really work if it's in a concealed area, right?
Oh,
So what
that's
if the
an interesting
universe was in a
concept.
concealed area, and it's kind of like a balloon where it like
it would
expands.
have to be a closed surface, by the way.
Yes, expands, and then once it expands, it contracts, because the force was like happened inside.
Yeah.
So you're mixing up an explosion and an implosion.
No, in an implosion. The
An
implosion
explosion
happens inside.
Yes, but an explosion is what you're describing, but calling it an implosion. An explosion is when you have expanding gases or expanding anything,
Okay.
and then it reaches the edges of the container, and the container can no longer hold it,
Oh,
so
yeah,
it
yeah.
snaps. An implosion is when you have something inside of a container, and you have something on the outside. I don't know what that hand motion was. Something on the outside that causes the stuff on the inside to
expand.
very fast, instead of expand, contract. And you can do this with an aluminum like soda bottle or soda can and some ice water. And if you heat up the air inside of an aluminum can and then put it like the top down into an ice bath, it'll cool the air down so quickly, and it'll have nowhere to there'll be nowhere for anything to come into it, and it'll crush the can. That Yeah, now that I'm thinking that through, probably not. Because if it's expanding, it's not like it's going to reach the edges, stretch, and then stretch back, you know, unless we prove that the outside of there is an edge to the universe, in which case the edge to the universe would have to be like silicone or a rubber band, you know. It would have to have some sort of spring constant, which I doubt. It'd be kind of too good to be true, in my opinion.
Ever expansive balloon.
Honestly, I don't know. I think the idea
What
that
kind of goes with
that
like
the universe is just empty.
Joe, what did you do?
Yeah, Peter, it's back. It's back. Don't worry.
What did I do?
You
Just shut off and turn off.
you
but you're
kicked-
Did I kick something?
you kicked something,
good,
Joe.
dog.
Okay,
Good job.
I'm sorry.
Well, no, I'm talking about like.
Can they still hear us?
Yeah.
Okay.
I'm talking more of like. Jeez, I lost my train of thought.
I'm
'cause
sorry.
You kicked it. Oh my gosh, I hate you, Joe. I'm thinking more of Jeez, what was I thinking, Joe?
I don't know, but the microphone's still on me because Matthew didn't change it.
Are you sure?
Now it's on you.
Okay.
I'm checking if your audio is fine.
Let's see.
Doing my job.
Let me see what I was talking about.
Well, okay, switch
so,
it back to me.
universe
go
ever
for it, go for it, go for it.
expansive, right? So it ever expands,
Uh-huh.
but
It reaches the edge.
I mean, if there was isn't there? Well, doesn't who'd you Newton?
Who'd you call him?
Is it Newton or is the theory of relativity where
That's
every
Einstein.
Einstein's
Einstein is theorist relativity and special
Yes.
relativity.
So every action has an
Oh, no,
opposite
that's
and
Newton.
equal.
That's the third.
Newton.
That's
Third
the
law.
third law.
Third law of. I
Newton.
got them all mixed up. Every action
Man.
has an opposite and equal reaction.
Yep.
So if you think about it, that could also be the case with the universe. So if there was a big bang where there was an explosion,
Then there's
then
gonna be a big crunch.
yeah, universe collapsing
Hey,
on itself.
If anyone uses that term,
Not
you
wrong.
gotta give me royalties, man. I like that. The big
big
crunch.
And then you just get the candy bar crunch.
No.
The big crunch is
The
just a
big
big crunch. No, but like the universe collapsing on itself.
I suppose it's possible. I don't know that there's much evidence to back it up.
Oh, of course
either
not.
I mean, either way, honestly, there's
Uh-oh.
more evidence to that suggests it's ever expanding.
It exists, Joe.
What?
The big crunch is a
No!
hypothetical
No,
scenario
that was
for the
so
ultimate
good.
fate of the universe, in which the
No.
expansion of the universe eventually reverses and the universe recollapses, ultimately causing the
See, I was right. Yeah, my theory actually
There it
existed already.
exists. There it
I-
exists.
But that
I-
makes sense. It makes
I-
sense that it exists already. It makes
I
sense.
guarantee. I swear, I had never heard of that before.
Well, of course, none of us have.
I literally
We
came
don't-
up with that at the like.
we don't
I
research
literally
this.
came up with that. Well, I do, but I've never seen the Big Crunch before. But I literally came up with that on like in my head like right
On
now.
the
I'd
spot.
never heard of that before, and I was so proud of that, man.
Take it away.
I was so proud
That's a
of
big
that.
What's
middle
that saying?
finger to
Every,
Joe.
Ah.
every thought you've ever had is not
It's
like
yeah,
everybody's
your
not
thoughts
thought
aren't your
about it
own.
before.
Your thoughts aren't your own. Whose ideas are yours?
Yeah.
That's a Jordan Peterson quote right there.
yeah.
Man,
Paul
that's
Davies.
disappointing.
Paul Davies.
That's disappointing.
But yeah, so
I liked that, the Big Crunch.
the big crunch, time crunch.
And they said the same thing you said.
What are the chances? What are the chances?
Wait, what do
The
you mean?
same exact. It is literally
Well,
called
Joe
the
said
Big Crunch. Somebody
and
already
someone
coined
called
it.
The Big Crunch.
Somebody
You could've
already
called
coined it.
The Big
Man.
Recollapse.
Yeah, or the Big Condensing.
The Big
I mean, the
Condensing.
Big Crunch just sounds
the
better.
collapse. I mean, yeah, the
Man.
collapse of the universe. Yeah, it makes sense. Every action has an opposite and
It
equal
says the
reaction.
Big Crunch may be followed by another Big Bang, creating another. new
Yeah, so
universe.
we were literally
It was
just
describing what it is. I was literally describing what it was. That's okay, yeah. But I mean,
And the last minutes
it's
of
a cool
temperature-
theory.
Temperatures of the universe would be so great that atoms and atomic nuclei would break up and get sucked up in an already coalescing.
Oh, all
Joe's
right.
depressed.
I'm
he's
checking out for
tired.
the day.
Joe's going to sleep. All right, it's me now, guys. What's
Dog
up?
Cameron, dog
Welcome to the Cameron Show.
Yeah!
Where we talk about stuff that Joe
Cameron
doesn't
Cast?
like.
Cameron
The
Cast?
Cameron Cast.
Yeah, the
Cast?
Cameron Cast. Welcome to the
Banned on the first show.
overtime. Overtime.
We'll put a big
Cameron
sign above
Cast.
your head next podcast that
LED?
says Cameron Cast.
An LED one?
Overtime. Cameron Cast.
Actually, I should make an LED that says AstroCast that goes above us.
The 2011 Nobel Prize in Physics was awarded to researchers who contributed to making this discovery.
Ah! If I was just a few years earlier on this, I could have won
Been
a
a
Nobel
genius.
Prize. Are you kidding me?
Well, it said
Ah,
people who
man.
made- no, Joe. It said people who made this theory also won a Nobel Prize for something else.
Oh, okay. I was gonna
Yes, no,
say.
no, but I'm just saying your thoughts are on the same wavelength as Nobel.
Man, I thought that was
Well,
so
no,
original.
Cause I was Matthew. I was the one that originally said it.
It's all going to Cameron.
It's all
on
me.
Cameron.
I've got the philosophical
Man.
mind.
Man.
I get
Oh,
it
I
from
don't know
my
about
uncle.
that. I don't
I
know
get
about
it.
that.
I get it from my uncle. My uncle, his name is Jack. He's a
Sound
cool
on
guy.
podcast.
He's very philosophical. He just turned 70. That's actually the reason why I cut my hair
Oh,
and
wow.
shaved my
Because
beard.
your uncle turned 70?
Yeah,
Huh?
I was going over to his party at my cousin's house.
Cool.
Surprise
It
party.
says a more
See, he wouldn't shave it for us.
Screw him. I don't like him.
It says a more specific theory called the Big Bounce proposes
Bounce!
I have heard that.
Collapse.
I have
You've
heard
heard
that.
that
I have heard the
The
big
big
bounce.
bounce?
Yeah.
I actually
Where
haven't
it goes like this over and over again.
It's so hard to like keep flicking the buttons like, oh, who's talking? So
Yeah.
they get mixed up a little bit.
Man,
Well, if you have
I
to
was
think
so
about
proud
it,
of that one.
if you have to, if you think about it, everything has to have come from one thing beforehand. Because how did we get all these extra particles, all this Earth, all of this? It had to have
Well, if it
been
came
coming from something.
Yeah, If it all came from something, how did that something get there from nothing?
Because it came from something else, right?
Okay, well, where did that something come from?
Another thing.
And where did that thing come from?
Another thing.
I think ultimately the point that I was trying to get
The
at
loop
before we got interrupted, I don't like that.
You don't like
I don't think it's in actuality. I
Well, I think it's just it's a line, but it also can be like,
well, it can't be a line because if it's a loop, in your theory is conservation of energy, conservation of mass can't be. Well,
it doesn't exist within the 2D space. It doesn't exist within the 3D space, because we can't understand it.
Well,
properly.
okay, that's fine, but it has to be closed. Whatever it is has to be closed.
It's like the Mobius strip type thing.
Well, that's fine, but whatever it is has to be a closed surface or a
Yes.
closed volume or a closed.
Where one point in time and another point in time are non-existent, but at the same time existent.
That was the worst explanation I've ever heard in my life.
Where time
No.
and space are both existent and non-existent
So
at the same
with
time.
that,
where
with what you're saying
loops.
is, what you're saying is literally that space and time are non-existent. We are non-existent. We have come from nothing. We will go to nothing, and nothing has ever existed, and nothing ever will exist. We right now are a blip in time and space that doesn't even exist. I refuse to believe that.
we are thoughts.
See, what the way I look at it is we have solid evidence for the Big Bang. The Doppler shift, everything came from one point. You know, I get that. And the thing that is hard for me to wrap my head around is, you know, how can something come from nothing? I don't like the idea that it's all been a loop because what created the loop, you know? And I really don't like the idea that it's just a blip, but that's what I'm getting
A
at.
6-dimensional being.
That's what I'm getting at is
More than 6
there
dimensions.
has to be I think there's something, and that something in my opinion is God,
It
that-
proves video
that-
games are real. We are a video game.
No. that physically made the universe. Oh, hey, look, it's a bug. Catch it. Catch it.
I did.
Catch it.
Duh.
Don't
No,
throw it
I-
on me.
No, I
It's a bug.
killed
It's
his
a bug.
leg.
It's a bug. It's
Oh, that's right.
His leg, Joe.
I don't want to see his leg.
I.
Next time have chopsticks, don't you?
You know what? He detached it because he thought it was you were gonna kill it.
Yeah.
Okay. Well, anyway.
You were gonna kill it.
No, I was trying to grab it. Well, there it is.
Yeah, it just knows what consciously Cameron is thinking about. It's
Yeah,
he's
I
gonna
doubt it.
kill me.
I want to grab.
Oh,
your
and now it's up in
leg.
the attic. Okay. Well.
That was a tangent and a distraction and
Yes.
a half.
Yeah. I basically I think God created the universe. Is
Well,
I
yes,
think.
that's how it is.
Hey Joe, is there infinite universes? And like
I
every
don't
action-
like that theory.
Everything I'm doing right now is done by another guy. I mean,
So,
another
Yeah, that's
being?
the multiverse theory, and Neil deGrasse Tyson is a proponent of that. I am an opponent of that. I don't think the multiverse exists, and I don't really like it because I don't like I like the idea of uniqueness of our universe.
Well, when you
because
explain, hold on, let me
Go for it.
let me
Offer a
interject
counterpoint.
here. I'm not
Oh,
counterpointing.
okay.
I'm,
Offer a pro point.
it's not a pro point either.
Oh, offer a
It's-
neutral point.
It's a neutral point.
Okay.
So when you are talking about a multiverse, you're talking about one time strip that splits off.
Not necessarily.
Is that so? Then what exactly are you
They were
trying to?
saying that since the universe is infinite, then that means there should be another universe over there. And if there's infinite, there should be infinite possibilities. And there's
So like a
infinite
ring of
possibilities, then
infinite
this
universes.
should've
Not
happened
necessarily a
again.
ring, but essentially what the idea is that there is evolution among universes, and universes can be thought of as like species, and essentially there's all these universes, and if one of them bears life, then that universe is successful, and some universes are more successful than others at bearing life, and the ones that bear life are able to produce other universes, or you know, and whatever, or maybe it's not bearing life, but maybe making white holes. Maybe, you know, if a black hole is formed, a white hole creates another universe somewhere. Maybe that was our Big Bang. That's another theory I've been reading about. One second. But yeah, essentially the universe then would be some sort of natural selection evolution, like Charles Darwin,
But this is what
of
I'm
where
trying to say.
a universe would be successful if it makes black holes, because those make other universes, and it'd be like evolution like that.
So you're saying it's all at one time or all at one space?
I don't know. It's probably
'Cause it
it
goes
probably
into-
transcends time and space.
So that would, well, if
It would be
transcends
extra
time,
dimensional. There would be
that-
no
yeah,
dimensions.
It would be, and that wouldn't make any sense because. The
Well, to
dimension-
us.
Well, because
Mathematically, it makes perfect sense.
well, yes, but how do you exist in a dimension that we can't? That
You,
one can't.
no, no, no. You
perceive?
don't. You don't exist outside of it. You can, nothing can exist outside of a universe.
Well, yes,
but there
I know.
are multiple universes. That's the theory.
No, what I'm saying is like, is it because it would have to be in the same dimension, wouldn't that?
Not necessarily.
So you're saying that life could basically that's what I'm trying to say is like could life exist in a separate dimension from the dimension that we are in,
Who knows?
right?
Because
You can't think, because from what we perceive, you can't exist on one dimension because life can't exist with one dimension.
two-dimensional life? Look it up. I don't know.
Because atoms don't exist on a two-dimension singular dimension. They exist in a three-dimensional
That's true.
space.
Atoms do not exist in a
But it goes
anything
into
other
the
than
string
three
theory
dimensions.
that you're talking about, where it's
So with the string theory, though, things that are smaller than atoms technically could be interacting with other dimensions of where the reason we don't see them or perceive them is because they're small and wrapped up around themselves and really tiny at like the origin of a coordinate system.
Could exist in a 2D universe. Philosophers and physicists.
Okay, well we don't care about that. But
But yeah, see where I'm getting at? It's like
yeah. So that's just because the building blocks of our universe are
Yes.
made up of
And that's
something
what
that
we can
interacts with
perceive
3
and
dimensions.
understand.
On a spatial level, though. On a time level, they could theoretically interact with infinite dimensions.
yes.
That's my theory, though, technically. But
Unless there's a theory that is exactly the same as been published before.
oh, probably. My big crunch idea was stolen 12 years ago.
you mean
so
my big crunch idea that you
I coined the
supported?
term. I coined the term.
You coined it, but I had the idea.
Mine would have been more popular.
Ooh. Joe,
Yes.
the James Webb Telescope finished aligning today.
The James Webb Telescope finished aligning today.
Yes. And it doesn't say when it's going to be ready, but it just released new images, and they look pretty cool. I'll show it to you.
Okay. Well, you guys should look up the images from the James Webb Telescope.
You can barely tell anything, but
I was expecting something much more overwhelming than that. It's kind of underwhelming.
it just focused on star fields. That's all I said.
Oh,
With
okay.
each instrument. So they're individually doing it. They're still
Okay.
doing tests, basically. But it's getting closer and closer.
Here's another kind of weird theory, not really theory, but just thought. Imagine so. We perceive thoughts, right? We have our own thoughts. So what if we're thoughts of of something else that's thinking? And
Well, I
the
mean,
universe created
if
by someone's
Tec-
thoughts.
technically, that would just be God.
Yeah.
Yeah.
But we're just thoughts. In an image.
So, what is a thought to an extra dimensional being?
Third dimension.
What? No.
Their thoughts are the third
No,
dimension.
it's an extra. Well, why 3? If it's an extra dimensional being.
They can think and well, yeah, they could think.
They said it's full of stars, the telescope.
It looks like full of stars.
It could be just like well, in a sense, that would kind of support like the fourth dimension thing, where like the fourth dimension can see everything in the third dimension.
I guess. Yeah, I
That was
guess.
a zoom in
So that
as
could
far as you
that
can
could be just like since it's the fourth dimension, all the thoughts processed by the person that's in the fourth dimension, quote unquote, the person. I'm just trying to kind of explain what I'm saying. Matthew, is this even on me?
tell. Yeah, it's on you.
Yes,
Okay.
it is.
I just wanted to make sure.
It wasn't on you while you were talking previously. It was on me.
Oh, great.
Now it's on you.
These images.
But yeah, so it's the thoughts processed by the fourth dimension person.
Mhm.
I'm just explaining. Is the third dimension. The thoughts are the third dimension from the person that is
But
fourth
we
dimension.
don't think in 2 dimensions.
Well, that's true.
We think in 3 dimensions.
Well, we think whatever.
We also think in 4 dimensions.
Oh well, yeah, out of body experience, right?
No, like
Or-
like we can picture something moving.
Well, yeah.
That's 4 dimensions. Technically, we can picture things accelerating. That could be seen as 5 dimensions, because you have 2 dimensions of time and 3 dimensions of space. I mean, the jury's still kind of out on that whole dimension thing.
Well, yeah. Of
And
course.
it's just really hard to wrap your head around of something like that, because we only perceive anything in 3 dimensions.
We perceive in our own perspective.
Yeah, that goes back to what we were saying at the start of this. Humans can only see things in our own perspective. So,
Matthew, are you swapping properly between us?
Trying.
Matthew's half
says
asleep.
An infinite regress can't exist since it can't go on forever.
What's that?
Edward says an infinite regress can't exist since it can't go on forever.
An infinite regress can't exist since it can't go on forever. There's no such thing as an infinite regress. You can't infinitely regress because you would go negative, and things in reality, there is no such thing as negative space
Well, if you
unless we
think
can
about it,
prove
hold on.
there's negative space.
Infinite regression could be thought of as the point in time, in a sense, Joe, where you're mentioning where everything kind of just goes a lot slower.
Oh,
Infinite.
so that would be like the limit of time as time approaches infinity.
Yeah.
So that's not infinite regression, though. That's infinite time on a exponential or logarithmic regression, or damping. What Edward is saying is infinite regression cannot go on infinitely, and that's true. There is no such thing as infinite regression. So I'm not sure what he's referring to in that case.
Well,
What
let's
he's
see
referring
what Edward
to.
says.
Well, that's what he said. You
Well,
can't have infinite
saying,
regression.
backing up to what he's saying.
Because, what was he? I'm trying to realize what he was talking about.
Well, he might be explaining what it is that he's trying to talk about in this right now. Edward, explain it further.
Yeah, we're like in reference to what about infinite regression? Because I don't think we said anything about infinite regression. But I mean, you're right. You can't have infinite regression because that's an oxymoron. You know, that's a self-contradicting term. You have to hit zero at some point. You can't infinitely regress. Except actually no, you could have an exponential decay, and that's technically, well, but that's not infinitely regress. I guess it could be.
Well, now you're trying to explain
Well, okay, define infinite regression
and decay.
Yeah,
the same thing.
define regression. If you mean infinite decay, then I would say you absolutely can have infinite decay because you would never reach zero in that case. If you're talking about linear decay, then that wouldn't be decay. First of all, that'd just be linear regression, and yeah, that can't go on infinitely, because we have physical limitations in our dimensions. You can't, go past zero into negative space. I mean, well, theoretically you can.
What exactly is negative space?
20-minute tangent.
No. It's dark matter, and no, so dark matter's not negative space. Negative space, actually, there are concepts on the internet that I've researched a long time ago about negative space, and it's highly convoluted. But that's hard to wrap your head around, man. In a negative space, like it's almost like inverse. Like if you have the inverse, it kind of reminds me of taking the inverse of a matrix.
Well,
because you can't, or like dividing by zero.
So would negative space mean that you would be going to a different dimension?
No.
Cameron's onto something.
I'm onto something.
Definitely
guys.
not onto something there. So pop culture has tainted your view of dimension. Because a dimension is just a physical
I was
unit.
joking, right?
I do know you were joking, but I still do want to address it. Because a dimension isn't like a place you can go.
Yeah.
It's not like you can, like just hop into a Doofenshmirtz Evil Incorporated time dimension portal thing.
An alternate reality is different from a dimension.
Yeah, an alternate reality, it's kind of, in pop culture, it's interchangeable with like, a dimension.
Yeah.
Yeah, but if you go into a different dimension, you are no longer three-dimensional. You would be whatever dimension you went into. But you can't go into another dimension. But yeah, that's what Matthew just pulled up. That'd be negative space is like having negative mass or negative time.
How then?
That's not really like something that we can perceive or observe as being possible.
Due to the fact that we live in the three-dimensional.
No, not due to the fact that we live in three dimensions. That would be the same no matter how many dimensions you perceive in.
Negative energies and negative energy density are consistent with quantum field theory.
Negative energy is completely fine because you just define a system, and energy going out is just negative energy. Negative mass is not polar. there is no positive or negative mass like there is positive or negative charge or north and south magnets.
But there is more mass and less mass.
Yeah, but there's more positive charge and
Well,
less
yeah.
positive charge, and then there's more negative charge and less negative charge, but that's not the same.
Yeah, I know. That's what I mean. It's not the same.
Negative mass would be... That would mean instead of warping space-time towards the mass, it would be warping it away. And I guess maybe negative mass would be a white hole then.
Yeah, that's exactly what I was going to mention.
In that case, the singularity might be negative space. You know, the point at which a black hole turns into a white hole and the white hole turns into a black hole.
Violate one or more energy conditions.
Oh yeah, it would absolutely be a violation of conservation of energy and conservation of mass. Wow, that's a trip right there. Because that takes a lot of... we would need to redefine a lot of physics.
With negative mass, if you push something, it accelerates towards you.
Yeah. Like, okay, hold out your hand. Okay, if I push Cameron's hand like that, it goes that way.
Yeah.
If I pushed negative mass, push against my hand, it would go towards me.
Yeah.
So, hold it normal.
When you push, I would be going towards you.
When I push, it would be like, here, it'd be like that. No, okay, stop. No, but honestly, it like, if I push you and then go towards me, you're supposed to go towards me.
Oh, sorry.
Ready? Ready?
You're just going
One,
through my
two,
fingers.
three. Okay, this is a terrible demonstration.
Yeah, you're just going through my fingers.
Essentially,
I'm so confused.
If this is my negative mass, if I push it being positive mass, I would push it and it would accelerate towards me.
Supposedly,
So it'd be going like this. Basically, think of it.
Conditions for a negative mass by pulling rubidium atoms, just a hair above absolute zero, creating what is known as Bose-Einstein condensate.
Bose-Einstein condensate.
Thank
Yep.
you. This state predicted by a name I cannot pronounce, and Albert Einstein. Particles move extremely slowly and, following the principles of quantum mechanics, behave like waves. They also
only Matthew had a
synchronize
mic.
and move in unison, so as what is known as superfluid, which flows which flows without losing energy. Oh my god.
So it sounds like we need to do some research on negative mass, because that sounds like something that my dimension theory needs to get a handle on, or kind of address. That's interesting.
You're
That's
welcome.
really interesting. Didn't Matthew bring it up?
No.
Oh, you brought it up?
We have the tape, so we'll just run it back.
Well, I said
Instant replay.
We kind of brought it up.
Well,
it was.
no, you brought it
I
up.
said.
No.
I said, you know, you can have a larger size of mass and a smaller size of mass, and then like
Yeah, that's the thing, is like...
It's 9:45, guys.
mass
45?
attracts together things. So the opposite of that would be repelling,
Yeah.
which could, compared to
So
the
that's
black hole, the
interesting,
white
though.
hole.
That's really interesting that you bring that up, though, because mass attracts other mass. It's not like that for like charges of electric charge or magnetic charge, or it's not magnetic charge, but magnetic field. You know, opposite attract, the same repel. Same charges repel, opposite charges attract. So that's interesting, because all mass attracts to all mass.
Mhm.
So I guess that would mean negative mass would... All negative mass
Repel.
would... So would all negative mass repel all negative mass?
Yeah.
Or would all negative mass repel
Mass.
mass?
I think it would just repel everything. Both.
Well, if it repelled everything, then...
Well,
and,
no.
and mass
so-
attracted...
So then, negative mass attracts mass,
Uh-huh.
but wait, hold on.
They're both pushing-
No.
they're both
So
pushing
wait,
away
hold on.
from each
Hold on.
other.
Hold on.
They're both
Wait, let me
pushing
explain. Let me
away,
explain.
and they're
So
both pushing
mass
away.
attracts mass, right? So then the opposite would be negative repels negative.
Mm-hmm.
So then what happens if there's a negative and a positive? It would go the same as electrical and the other things it would attract. Right?
Well, but like charge...
Oh no,
so,
it would be opposite, so it would repel.
You know what it would be? Yeah, you're right. Because with electric charge, same charges repel, different charges attract.
so if it was
with
the
mass,
opposite, it would be
It
the
could
opposite.
be... It could be same charges attract.
So negative attracts.
Negative and positive mass would
Yeah.
then repel. This is interesting. That could be why we don't see any negative mass.
Yeah.
Because this is all positive mass, or technically,
Quote unquote.
quote unquote.
And that's
And
what
we're actively repelling all negative mass, and we all know that gravity over large distances is the strongest force, theoretically. That's an interesting concept right there. That's an interesting concept.
I wonder if it's been coined.
I'm sure it has.
What?
So
What has been coined?
it could be the reason we might not see or observe any negative mass is because negative and positive mass, based on our discussion right here, would repel each other. And since gravity, or the attraction of mass, dominates over large distances like the universe, the reason we don't see any negative mass possibly is because all of the negative mass has been repelled by all the positive mass, or vice versa.
And so it could be, well, that could be the makeup of the universe. So all positive mass is inside, and it kind of makes sense with the atoms.
Mass is on the outside.
It's kind of like atoms.
Dude!
So
The
wait,
universe
it's
is- oh
atomception, dude. So it's literally atoms. So we are atoms, bro. We
Dude.
are atoms.
Oh my god.
What do you mean we are? Of course we are.
Dude.
That's funny.
Oh my god.
You know, and
We are
I
on
think
the
I've
same page. Yeah,
I've
yeah.
thought of that before too.
So, okay, let's quiet down because we're totally clipping the mics.
Yeah,
Dude.
The mics went crazy.
Dude, we need to chase this theory.
So this is
because
the bomb and seas theory.
Imagine this. All the positive mass is at the center and all the negative mass is on the edge of the universe.
Which
and
would
that
make sense
is
in the
edge
atom.
of the universe.
Is
Because
all the negative.
all the positive
And so-
is on the inside of the
and since
atom
we're-
and all the negatives on the outside. And that would be why we don't see negative mass. It's because it's all on the outside.
And
'Cause
you
it's
know-
all
you know what-
actively repelled by
Well,
the.
guess what? That would also mean that since all gravity, so the universe is ever expansive, but it
Yep.
would also back up the reason why it could
It
contract
could
too.
contract back onto itself because the negative
Gravity.
mass would repel.
Well, that and gravity.
That makes sense. That
Well,
makes sense.
mass.
And then you'd have a spring constant at the edge.
A what concept?
Spring constant.
For what?
Dude,
know,
we've just
we-
explained the universe.
Hold on. It can be disproven.
Well,
No,
yeah,
no.
it could. It totally
So,
could, but it makes sense.
Negative mass violates a lot of conservation of energy and conservation of mass, I do believe.
Well, that's just based on the physics and all the preconceptions that
That's
human nature has
That's true.
thought of up until now.
But there's a lot of evidence backing them up.
Well, there's a lot of evidence that also proves that
Not
people
really.
haven't come up with everything.
Well, that's true, but we would have to back this up with a lot of math
yes.
and a lot of observation, but
It's a theory that's worth.
that's a pretty cool
anything.
idea. You don't see anything?
the
Bauman-Sees
Bauman-Sees
theory,
theory.
or the Bauman-Sees
What
hypothesis.
would I even look up? I don't
Negative mass separated from positive mass at Big Bang.
But yeah, that would make sense, and it would go with the atom structure too,
You know what
where
that would
electrons
also
are
go with?
around and the protons and
You know
neutrons
what
in
that
the
would
middle.
also go with?
What?
We came from nothing. Do you know why?
'Cause-
Because if we came from nothing and went from nothing, if we have positive and negative mass, would those
would go
technically
back to
annihilate?
zero.
Yeah, it would go back to zero. All the charge in the universe is we already know that all the charge in the universe is if you add it up, it equals to zero, because all the positive charge there are the same amount of positive and negative charges theoretically in the universe. So because that wouldn't violate conservation of energy, you know, there's.
Oh, hold on.
Oh no! Oh no!
I think I found something.
Oh no!
Well, it might not be the same, because we've come up with a lot of things here.
This
However,
is
concept does seem to answer some intriguing questions: why the universe is expanding, whether expansion is acceleration.
Okay, well, we weren't talking about
large-scale
expansion.
distribution. No, I just
Or
read
maybe the
something
center of the
title.
universe is negative mass, and that's why
It
it's
could
expanding.
be the opposite.
Yeah, maybe that the center of the universe is a
And that
negative mass,
explains
and
why I
that's why
said
it's
that there was
expanding.
something in the middle, and
It-
that's why the reason
Everything's
everything
expanding.
expands.
It could be that way too. Maybe there's both.
Or it could be that's why it's revolving.
We could be in rings of the universe, of,
Atoms.
like
well, that's why I
negative mass.
explained atoms, and we make
Yep.
up atoms.
Yep.
And then what if
At
we?
or just after the Big Bang, when mass came into being, particles having opposite mass would immediately repel each other. The positive feedback effect would increase the repulsion, and because both positive and negative masses existed in equal numbers, there was initially no gravitational presence, so no inertia. In an instant, positive masses and negative masses would be accelerated away from each other to relativistic speeds. Inflation with a vengeance? What the?
It already exists.
Industries to speculate regions. It is only when there is a numerical equality between inertia.
Gosh dang it! I hate people. They're stealing
That's the
our
second
ideas.
time today.
Well, hold on. There's still the thing where
That's the second time today.
so atoms make up us, but what if we make up atoms?
No, I mean,
Like in the larger
I
sense
get what
scale.
you're saying, but it's more of a metaphor at that point. But man,
That'd be cool.
this is exactly what we were saying.
But it's cool. It's cool to talk about it.
Does
I
math-
thought that was so
Well,
original.
That just shows that we're like-minded to some.
Yeah,
of
I
the
guess that means.
greatest
I guess that
philosophers
means we're on the right
in
track.
Time.
I guess that means
history.
we're on the right track.
If
So
two separate thoughts came to the same
yeah,
conclusion.
great minds think alike. I guarantee you, me and Cameron have never like seen those
No,
this
I
theory
don't
before.
search up this in my off time.
So this is a man.
What happens when me and Joe get together
Yeah, we just predict other people's theories apparently.
without knowing about
Bro,
them?
there's so many
Ugh.
articles I have to vet through.
Man, I really liked that one. I mean, we can still chase it, but
I saw Joe get really hyped. I was like, did I miss something? I was focusing
yeah,
on this. I'm like, oh my God.
dude,
Something's
like
happening.
that, because that made something click. You know,
Yeah.
that was like a click
Oh,
right
it
there.
made
It was like that filled in a lot of gaps.
Well,
for
it filled
me right
in
there.
exactly everything that we were talking about prior to this too, and a lot of things that I brought up
Man.
with there being a
Man.
balloon and it expands and it can contract.
Yeah, I don't know about a balloon, but yeah.
Well,
yeah.
I mean, just as a metaphor.
Yeah, yeah.
You know.
Yeah.
It's a metaphor of a balloon
I only see,
expanding
like,
and
3
contracting.
articles on it, so I don't think it's
Well,
highly.
Let's
highly
write an article,
discussed.
Cameron.
Well, this is our article.
Let's write
It's
an
a
article.
video.
We'll write an. I'll write. We'll write a paper. We'll draft it up.
I could be wrong though. There could be more research papers.
Oh, there probably are, but we'll just draft it up and say, hey, roast us. You know, we'll publish it and say, and get
not
collective
roast.
roast by the scientific community.
Not even just a roast. We just, get more information. We
Yeah.
want more information. Back
Isn't
us up.
The scientific community
Prove
supposed
us
to be
wrong.
like building up each other. It's like, oh, that was wrong, but I'll help you out with this. And
Oh,
help you
the
with
scientific community is just as toxic as any other community.
this.
I tell
You're
you
wrong.
what. Oh no, absolutely. It's people who are so prideful that they cannot be wrong. That it's like, they literally go to like. It's over these theories that like, in the grand scheme of things, does it really matter? I mean, yeah, it's cool and all, but
Well, I mean, because
Does it
they're just
really
like you,
matter?
Joe, where you're like, oh,
Yeah, well,
like
no.
that.
But the difference is for me is I'm not gonna go fisticuffs over something like
Oh,
that.
yeah.
I'm not gonna be like. I mean,
'Cause
if
this
I'm
is just
wrong,
a
if
hobby,
I'm
it's
wrong,
not our
I'm wrong.
lifetime.
Well, even if
thing.
it was my lifetime achievements, at least I've achieved. That's not an achievement just to say I'm wrong. That means I learned something.
Yeah.
Joe,
There's a lot of pride amongst, especially
Humans-
professors, where they just can't be wrong.
humans want to be remembered after they die. And have your name
You can
attached to
still.
something
I tell
great,
you what. There's a
something
lot of
big.
there's a lot of people who have been wrong, who we still know the name of.
Yeah.
Niels Bohr was wrong about the atom, and we still know the name of him. Albert Einstein. Actually, Albert Einstein hasn't been proven wrong yet. That's something that's pretty. It's pretty cool.
The universe is falling.
Newton has already been proven wrong. Einstein proved Newton's law of gravitation wrong. But we still know Newton. People's life's work are failures all the time, and we still know their names. It's not a shame to be wrong. That means we collectively learned something. Now, what we learned is maybe that's not the right way, but it's still,
Still, he advanced science.
yeah. It's still advancement. So, I think we're gonna kind of wrap it up here.
It's been a total of an
So,
hour and
in
55
summary-
minutes.
Yeah. So,
Science is a collection of hypotheses that may or may not be disproven by other
Yeah.
hypotheses.
so it's the scientific method. Just because something is called a theory or a law doesn't necessarily mean it's beyond disproving.
Mhm.
That doesn't mean that some conspiracy theorist on the internet is right about the Earth being flat, but that means that if you have the time, the evidence, and the reason, and you come up with some model that contradicts something, it's possible that the thing you're contradicting has some sort of incorrect presupposition.
What is that?
Was what?
Complicated one.
Which complicated one?
Schrodinger's?
These are not complicated. This one.
Oh,
Schrödinger.
Schrödinger mass?
Yeah.
Well, there's some.
So Schrodinger has to do with probability, so I'm guessing that's quantum something. Psi is generally only viewed in either quantum or the columns of psi and matrix algebra. So my guess is it has something to do with probability and quantum. But Matthew just showed us a picture of some equations on NASA's website, and one was the Schrodinger mass equation. I don't know too much about it. So.
It was based off the negative.
Okay.
Negative
Based
mass.
off negative
That's
mass.
what I was assuming when you showed it to me. I
Yeah.
was like, that's
Okay,
probably
well,
negative
No, I
mass.
wouldn't bring it up.
We're gonna end it here. So this is Matthew's cue to bring up the final final
researching.
break in the ads. This is Matthew's cue. This is Matthew's cue.
Not intro. Where are
Nope,
we?
intro ads. There you go. One. There we go.
We're
Okay.
just lost in there. The biter will work.
All right. So thank you guys so much for watching. Yeah,
Poggers,
subscribe to the YouTube
subscribe.
channel if you enjoyed this episode, so you don't miss another episode of the AstroCast Live. You can find us everywhere.
It says Mondays on there, Joe.
Oh, well, that's wrong. We're Fridays at 8 p.m. We are live Fridays at 8 p.m. on this YouTube channel. The audio version of this podcast comes out Mondays at 5 p.m. And you can follow me at joe.czol on Instagram. You can follow Cameron nowhere because he has no social media presence. And you can find this podcast everywhere you find your podcasts. Spotify, Apple Podcasts, Google Podcasts. And clips come out Tuesdays, Wednesdays, and Thursdays at 2 p.m. on this YouTube channel. And I think that's about all I have to say in regards to that. So, yeah. Unless anyone has some few last words for this podcast, I think we're going to wrap it up here. Anyone? Cameron? Any last words?
Yeehaw.
All right, well, you said
just
yeehaw.
need your last ha, boy. I don't even think they heard it. Did they hear it?
I got to keep switching. This is not easy.
Oh, I just went.
I don't think it was connected.
All right, well,
No, it was. I
thank
saw
you guys.